All right, so we are going to take a look at how to graph quadratic expressions by using the important features of a parabola. And to remind you, the important features of a parabola are the X-intercepts, the Y-intercepts, the line of symmetry, and the minimum or maximum, I'm going to call it the vertex. Now remember, you'll either have a minimum or a maximum, but not both. So let's take a look at problem 1. So that would not be what I want to grab. There we go. All right, so it is important to understand where to find each one of these important features of your graph. And so you will remember that the x-intercepts are found in the factored form expression. The y-intercept is found in the expanded form expression. And then the line of symmetry is the average of the x. And finally, the vertex is going to be your line of symmetry, the x-intercepts, comma, and then you have to plug in the line of symmetry into one of the two equations to find the vertex. And so let's take a look at number 1. So in number 1, we have a factored form expression. And in a factored form expression, we will be finding the x-intercepts. Now, on the x-axis right here, you'll notice that the y value is in fact 0, which means this thing has to equal 0. Well, if I'm multiplying two numbers together and I'm getting a 0, that means that one of the two numbers must be 0. So what I'm going to do is I'm going to break this apart, and I'm going to have two different problems. I'm going to have x is equal to 0, where I get the x right here, and I'm going to have, in my break, x minus 6 is equal to 0. Well, on this one, I don't have any work to do. It just says x is equal to 0. So one of my x-intercepts is in fact 0. For my other one, what's the opposite of subtracting 6? Adding 6. So I get x is equal to 6, which means 6 is my other x-intercept. So I will locate this on the grid. Right now we have 0, 0, and 6, 0. 1, 2, 3, 4, 5, 6. Now for the y-intercept. Now the y-intercept is in the expanded form, so I will have to actually go through and find the expanded form. So x times x is x squared. X times negative 6 is negative 6x. And I'm not adding anything here, right? So that means that my y-intercept is going to be 0. I'm adding nothing to it. So I have this right here. My line of symmetry is going to be found halfway in between my two x-intercepts. Well, what is in between 0 and 6? 3. So I'm going to put a dotted line denoting the line of symmetry at x equals 3. And remember, it's a vertical line, which is why I have the x equals, because the equation of a vertical line has my x value, because of the x equals. So now our vertex, we're going to have 3 comma something. So I'm going to take that 3 and I'm going to plug it into my factored form expression. Now I could plug it into my expanded form expression, but personally I like using the factored form version better, so that's what I'm going to do. So we have 3, because instead of x I'm writing a 3, times the quantity 3, because that's what x is, minus 6. So I have 3 times negative 3. Well, that is just negative 9. So then, let's go down on the line of symmetry to negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I'm ready to connect my points. I know my parabola is going to be symmetrical. So I'm going to try to make it as symmetrical as possible, knowing that I am not necessarily going to do a great job of it, but I'm certainly trying my best. And there we go. There's our first graph. Now for A2. I will be using the same process. First, I need to find my X-intercepts, my Y-intercepts, my line of symmetry, and my vertex. I see that I have an expanded form expression here, which means I will be finding my Y-intercept, which is the plane number. So I have a Y-intercept of 16. And so I'm going to count by 2s. So this is -4, this is 4, this is 8, 12, 16. And so my Y-intercept, I'll try to use the same colors here, is going to be at 0, 16. Now for my X-intercepts. My X-intercepts are found in the factored form expression, and this is not factored. So let's look at this. We have 16, and we're subtracting x squared. Is there a greatest common monomial that I can factor out here? Is there a number or a letter that goes into both 16 and x squared? No, because one's a letter and one's a number, and they don't share anything in common. So now I need to think, is this a difference of squares? Well, it could be. Difference of squares means we have a difference, which we do, and we're subtracting difference, my two square numbers. 16 and x squared are both square numbers. They are, so I do have a difference of squares. And you will remember that a difference of squares will be factored into a pair of binomials where you have one addition and one subtraction, and we're just going to take the square root of each of these. The square root of 16 is 4. That's going to go in the front of both my binomials. The square root of x squared is x. That goes in the back. And so I have now successfully factored it. Remembering that the y value along the x-axis is 0, we know that this is going to be equal to 0. And so let's go break it apart, make it equal to, let's get it by itself. Let's get the x by itself. So let's add x. So I get 4 is equal to x over here. Let's subtract 4, so I get -4 is equal to x. So my x-intercepts are 4 and -4. Let's locate that on the graph. So we have 1, 2, 3, 4. 1, 2, 3, 4. All right, there we go. And now the line of symmetry is going to be halfway in between 4 and -4. Well, what's in between 4 and -4 is just 0, because they're opposites, which means my line of symmetry will be 0, comma, well, if I plug 0 in, 0 squared is 0. 16 minus 0 is 16. And it's, lo and behold, it's right here. So I can go ahead and I can draw in my parabola. It goes through my x-intercepts and my y-intercept. And there we have it. Continuing. Oops, that's not what I want. Continuing. Now for 3 and 4, I'm going to go through a little bit faster here, because at this point, we should get the basic process. So we're looking for my x-intercepts, my y-intercept, my line of symmetry, my vertex. And we have an expanded form expression, so therefore my y-intercept is just that, 9. In my in factored form, well, I'm looking at this, I have a x squared, I have a 9. It really looks like I have a square binomial. So I have y is equal to x plus 3 squared. And I know that because 3 times 3 is 9, 3 plus 3 is 6. So I know I'm good on this one. Well, along the x-axis, y is 0. So what would make this whole thing 0? Well, -3, because -3 plus 3 is 0. And I only have one x-intercept in this case, because I have x plus 3, and because of the squared, I have another x plus 3, and both binomial pairs would give me -3 for my 0. So I go to -3, I put my dot, go to my y-intercept of 9, put my dot, and, well, what's my line of symmetry? What numbers is the average of -3 and -3? Well, it's just -3, so -3 is equal to x, so I can put my line of symmetry, and then for my vertex, we know that we'll have -3. Let's plug in -3. -3 times plus 3 is 0. 0 squared is 0. So this also happens to be the vertex. Sorry. And one little trick that I would like to show you really quick is this. You know that, oh, I guess I'll read this. You know that parabolas are symmetrical about the line of symmetry. Therefore, if this point is 3 spaces away from the line of symmetry, I will have another one right here, 3 spaces away. And there we go. For number 4, again, we have a expanded form expression, which will give me my y-intercept, which in this case is just my 20. Just set in my table. Now to factor this, I'm looking for a pair of factors for 20 that add up to 9. Well, what two numbers multiply to get 20 but add to get 9? 5 and 4. So we know this is going to be x plus 5 times x plus 4, and we know this is equal to 0. Break it apart, equal to 0. So on this side, I get x is equal to -5. On this side, I get x is equal to -4. So let's go locate them. So 1, 2, 3, 4, 5. I'm going to count by 2's on my grid. So we have -2, I guess that's not counting by 2's, that's counting by 1's, folks. So that's -4, 6, -8, -12, -16. Obviously this would be -20. But I want positive 20, so that's way up here. And we need -4, -5. And then our line of symmetry is going to be halfway in between the two x-intercepts, so that's -4.5. So my vertex is -4.5, comma something. We need to find that something. So let's plug it in. So I have, in the factor form expression, -4.5 plus 5 times -4.5 plus 4. So I get -0.5 times positive 0.5 for a total of -0.25. So that's about here. And so I can go ahead and draw my parabola. And my line of symmetry. Alright. Finally. Oh, that's not what I want to do. Finally, last one. Sorry about that. Alright, last two. So, and I'm going to go even faster here. So, -4 because it's an expanded form. This is going to, so two numbers that multiply together to get -14 are going to be positive 7 and -2. X times x is x squared, and 7 minus 2 is 5. So therefore, my x-intercepts are going to be -7 and 2. My line of symmetry is halfway in between those, but let's put in those things. So -2, 4, 6, 8, 10, 12, 14. So there's -14. Thank you. My y-intercepts or x-intercepts are going to be -7. 1, 2, 3, 4, 5, 6, 7, and 2. And so my line of symmetry is going to be halfway in between those. 7 sorry, -7 plus 2 is -5. Half of -5 is -1.5. So my vertex is at -1.5, comma, and let's plug it in. So -1.5 plus 7 times -1.5 minus 2. So over here I get 5.5 times -3.5. And so we can take your calculator. 5.5 times 3.5, and this one's negative. So we get -19.25. So hold on a second. So at -1.5, we're going to draw this down. Here's our point. And so here's our oh, crud. It's 2.5. Half of 5 is 2.5. Oh my goodness, and I did this all wrong. So I'm sorry about that. And so that gets us -4.5. So it's 4.5 times 4.5. It's amazing when kids start running in, then I aren't able to concentrate quite as much. So we're right here. And so here's my line of symmetry here. It's the price you pay for trying to go too fast, isn't it?
Sorry.
So I'm going to get rid of this one here. And now I can draw my parabola. And there you go. Guys, I need you to be quiet for 2 more minutes. All right, yes. Yes. Yes, that's fine. All right. Finally, last one. We are... All right. I'm sorry for the angry horde that's entering. They will be quiet. Thank you very much. All right. So we're in factored form here, which means that we have our X-intercepts. So my X-intercept on this one is going to be 3, because 3 minus 3 is 0. Over here we have -2, so we go 3 and -2. Half of 3 and -2 is going to be 0.5. So I have a symmetry right here. My Y-intercept is going to be 2 times 3, which is 6. So I go to 6. 1, 2, 3, 4, 5, 6. Put a dot. Great. And then my vertex is going to be 0.5, comma something. So 3 minus 0.5 is 2.5. 2 plus 0.5 is 2.5. And then, so that is 6.25. So I go up to 6.25, put a dot, and now I can draw my parabola. And there we go.